Okay, this is going to be the lesson that we missed on Friday due to our snow day. Oh, my son Wyatt's in the background fussing a little bit, so if you hear that, you can ignore it. I'm treating him just fine, so don't feel like you need to call social services. 64 to the 4/3, I'm going to simplify. Well, 64 to the 1, I can do this with my calculator, of course, but I know that this means the third root of 64 to the 4th. Third root of 64 to the 4th. But before I do any of that cube or a fourth power, I don't want to deal with this fourth power up here. I'm going to ignore that at first. And I'm going to do the cube root first. I know the third root of 64 is 4. You can calculate that in your calculator if you wanted to. But I know it's 4, and then 4 to the 4th is 4, 16, 64, 256. So that works out to 256. If you don't know how to do that in your calculator, I'll show it again. Give me a second to pull it up here. There's two ways to do this. One of them is to just do 64 to the, and then in parentheses do 4 divided by 3. 256. The other way is if you want to do the root. I started with a cube root. This right over here was a third root. So I'm going to press a 3 and do the math button and scroll down to the x root. The fourth option is actually third root. I can do third root there. But there's x root. So the 3 to the x root of 64 to the 4th is 256. I probably should have done that top stuff in parentheses in case it gets a little bit hairier. So I can sneak in parentheses if I need to. And I'm going to push pause and take care of my son for just a second. Okay, I'm not sure how long he's going to let me work, so we're going to try and race through this a little bit. A negative power flips over your fraction. And I can't have a non-whole number on the bottom of this fraction. I'm going to multiply the top and the bottom by whatever gets 9/4 to a whole number. Well, that's 3/4. I know that 9/4 plus 3/4 is 12/4. So now I have a to the 3/4 over a to the 12/4, which becomes a to the 3/4 over a to the 3rd. There's another way you can do this that I want to show you now, and I haven't shown you yet. And that's to think about, if I ignore the negative, if I ignore this negative and think about it as a positive, I know that the biggest whole number closest to 9/4 is a to the 3rd, a to the 12/4. So I want to get a to the 12/4 on top and bottom. So I'm going to multiply the top and the bottom. I have a to the negative 9 over 4 over 1 times a to the 12 over 4. I just multiply by that whole number, a to the 3rd. And that gives me a to the 3/4 over a to the 3rd. It's kind of a shorter way of doing the process from before, if you can follow and if it makes sense. Okay, we're going to be solving today. Solving these radicals. When you're solving a radical, you follow SADMEP like always. And here, we're going to have to check for extraneous solutions every time. Extraneous means it's a solution that looks like it works, but it doesn't. So basically that just means when you're done, you have to check. So I'm going to solve this one here on the left. First things first, I cannot just do 9 minus a half. 9 minus a half is not 8/2, or 8.5, excuse me, because of this multiplication. This is multiplication. I can't do subtraction before multiplication. So I'm going to subtract a 9 from both sides. I'm trying to get this radical by itself. I kind of want to think of this like it's some giant variable that I'm trying to isolate. So I'm going to get rid of the 1/2 now as well, the negative 1/2. So I'm going to multiply both sides by the reciprocal of -2. That gives me 2 equals the square root of 3x plus 1. Now I can put that in green, try and keep my colors the same. I want to get rid of the square root now. I've got the square root by itself. I've gotten this by itself. So I want to get rid of that square root. So I'm going to square both sides. I just multiplied by 2, now I square. Whatever I do to one side, I do to the other. And that gives me 4 equals 3x plus 1, which I'm not going to bother solving further. We just see that x equals 1. Well, now I'm going to check that. I'm going to take x equals 1, plug it in here. 3 times 1 is 3, plus 1 is 4. The square root of 4 is 2. Negative 1/2 times 2 is negative 1. And then 9 minus 1 is 8. So we're good. Here, same thing. Excuse me. Subtract a 4 from both sides. And get the negative third root of x plus 6 equals 3. Well, I can't have a negative third root. It's got to be a positive third root. So I'm going to divide both sides by negative 1. And then a cube root. Get rid of the cube by cube root. So this both gets cubed on either side. I get x plus 6 equals negative 27, which means that x equals negative 33. I'm going to check that as well, so I plug negative 33 in for x. Negative 33 plus 6 is negative 27. The third root of negative 27 is negative 3. 4 minus negative 3 equals 7, so that one's good also. That was when we just had one radical of some sort. Those are square roots or third roots. You can have radicals on both sides, and these can get a little messy. When there's two radicals, so sorry, it's not radicals on both sides, it's two radicals. When there's two radicals, you want to get them on opposite sides of the equation. Here on this first problem, they're already on opposite sides. So I'm going to square and I'm going to solve. X plus 5 equals negative 2x plus 1. I just solve from here and I get 3x equals negative 4, which means that x equals negative 4 thirds, not negative 3 fourths, which you might be tempted to say. I'm going to check that, and I've shown this to you once before a long time ago, but I'm going to show you how you can put this in your calculator kind of nicely to check it. I'm going to take negative 4 thirds, negative 4 thirds. I'm going to press this store button right here. That gives me that arrow. I'm going to store it as just some letter. I'm store it as A. I did alpha math to pull up A. Alpha math pulls up A. Now that's what A value is. So I can do the square root of A plus 5. And then I can do the square root of negative 2A plus 1. Now this might not, and those decimals are the same, so it checks that's a good thing. That storing trick might not seem any easier, but there will be times when these equations get so annoying that not having to plug in random decimals over and over is nice. The one on the right is significantly different than the one on the left because the radicals are on opposite sides, but there's also a term that isn't in a radical. We didn't have that over here anywhere. This is going to take a few more steps. I'm going to start by just getting the radicals on opposite sides. They need to be on opposite sides just to make it easier. It's not necessary for the math, it just makes it the most efficient way to do it. So I have this right now. This turns into the square root of x plus 3 equals 1 plus the square root of x. And now I'm going to square both sides. And on the left side, that's just one giant square root, so that squares pretty nicely to just x plus 3. But on the right side, I have a binomial. It's a binomial being squared. And remember, 1 plus the square root of x squared is not 1 plus x. Because you have to do 1 plus the square root of x times 1 plus the square root of x. It's going to come out to 1 plus root x plus root x plus x, because the square root of x times the square root of x is x. So it's 1 plus 2 root x plus x. Well, I'm still trying to solve this for x. I'm still trying to see what x equals. So I'm going to get everything away from this radical now. So I subtract an x, subtract an x, subtract a 1, subtract a 1. I have this. Divide both sides by 2. I have this. Square both sides. and I get that x equals 1. If I check it, square root of 4 is 2, square root of 1 is 1, 2 minus 1 equals 1, so we're good. That one wasn't actually so bad. This is the one that's really so bad. This is quite a bit. I'm going to subtract the square root of x plus 2 from both sides. That gives me root 2x equals 4 minus the square root of x plus 2. Square both sides. This is just like doing this. Like, I know this comes out to this. And so my A is just like 4, and my B is just like root x plus 2. This is going to come out to, on this side, 2x equals 16 minus 8 root x plus 2 plus x plus 2. We'll subtract 16, subtract x, subtract 2. So we subtract 18 and subtract x. And I get x minus 18 equals negative 8 times the square root of x plus 2. Now I could get that negative 8 to the other side if I wanted to. At this point, I'm down to a monomial over here. That's a monomial. I like monomials. I'd rather have that. I'd rather have what I have right now than have this. I could divide both sides by negative 8. I get x minus 18 over negative 8 equals the square root of x plus 2. And then from there, I would square both sides, and that would come out to an 8 or 18. 18. Sheesh. X squared minus 36x plus whatever 18 squared is. $324. I could do it like that, and you're going to see it's going to work out the same. If I change that, if I just leave this negative 8 where it is over here, if I just leave that right there, I'm going to square both sides, and I get the same thing, x squared minus 36x plus 324 equals 64 times x plus 2. Well, then I distribute the 64. Subtract 64x and subtract 128. Subtract 64x, subtract 128. I get x squared minus 100x plus 324 minus 128 is 296. I had to get everything equal to 0, so I'm solving a quadratic. I'm solving something with an x squared and an x left. Sorry, I'm going to pause it again. It's okay, buddy. Okay, I'm back. It's a good thing that Wyatt stopped me because I made an arithmetic mistake. 324 minus 128 is 196, not 296. Now I have this, and we'll make those red so they look crazy. I'm going to go back a step and kind of talk through this again. I had a big old quadratic. And a quadratic has to be solved with completing the square or factoring or quadratic formula or something like that. This one here at the bottom, when I'm all said and done, it actually factors quite nicely, but I'm just going to do the quadratic formula. And I'm actually going to do it in my calculator to save time, so just trust me, this comes out to 98 and 2. Well, those are the two possible solutions. We have to see if they both work, and there's a very good chance that they both don't work. So if I take 98 and 2, and take those solutions all the way back up to the top, I'm going to plug in a 2. And that's equal 4. the square root of 4 plus the square root of 4, that's really 2 plus 2, which equals 4, so that one checks. So I'm going to plug in 98. 2 times 98 plus 2 plus 98. 2 times 98 is 196, and the square root of 196 is 14. So we get 14 plus 10, which is 24, not 4. So this one doesn't work. 98 doesn't work, so the answer is x equals 2. That's when you have to check extraneous solutions. Okay, Wyatt, last one. Real quick, buddy. We're almost done. You want to help me with it, bud? Yeah, you want me to hold you? We can do it together? Okay, I'm holding you now. Is this all right? Oh, you got your hand all dirty. I'm sorry. We got to get rid of this 1/3 power, Wyatt. We don't like it. So first we subtract 8. Oh, look. 3x minus 2 to the 1/3. Oh, that equals 5. That's interesting. Oh, I'm sorry. That thing's on your pen. Okay, Wyatt. Now we got to get rid of that 1/3 power. My goal is to make this become a 1. That's the goal, is to make the power become a 1. If I wanted to write it like this, I certainly could do that as well if you find that more helpful. But it's good to be able to do it both ways. So I'm going to cube both sides. Wyatt, do you know what 5 cubed is? What is it? Oh yeah, it's 125. Good. (123 over 3). I should check this, but I'm not going to, because I have to get going before my sun breaks down. You should pause this one and try it on your own, and then watch me try it. Okay, good. I'm going to take both sides to the 4/3 power. I did 4/3 because 3/4 times 4/3 is 1. If you would rather, you could think of it this way. And first you would do that to the 4th power, and then you would do the 3rd root of all that. But I think that's more confusing at this point. So you end up with 2x plus 1 equals, well, 8 to the 4/3 is 16, just trust me. So 2x equals 15. So x equals 15 over 2. Again, I should check that. I do. It works. Wonderful. Anything else I need? Nope, we're done. Have a wonderful day. Get your homework done for Monday or Tuesday, whenever I see you next. And we're out of here.